Hello, this is Chapter 9, Articulations. This material was originally slotted for Module A3. In fact, if you look at the objectives for A3, objectives 13 through 17 cover articulations. Excuse me. We have now moved that to Module A4, so this material covered today, in fact, all of the material coming out of Chapter 9, there are 5 objectives, will all be tested in Module A4. So just keep that in mind. Articulations. When two bones articulate, they come together. And when two bones come together, they form a structure known as a joint. Joint structure determines the range of motion associated with that joint. So it determines the types of motions that are possible. If you just kind of think for a while, the head of the humerus articulates with the glenoid fossa of the scapula, creating the shoulder joint. And that particular joint has a very wide range of motions. We can move our shoulder joint in a lot of different directions. Compare that to the joint that is formed between the two parietal bones as it forms the sagittal suture. There is no motion associated with that joint. So joints, again, they can be, we'll see in a minute, categorized by their range of motions. But that is what I mean when I say range of motion. It's the amount of mobility and the direction of that motion, of those motions. We'll find this theme as we run through articulations, that the strength of the joint decreases as the mobility increases. Let's start with mobility. Mobility is the amount of movement. And again, if we go back to the two examples I just used, we had the shoulder joint and the joint between the two parietal bones that form the sagittal suture. These have very different mobilities. The shoulder joint has a tremendous amount of mobility, while the sutural joint has no mobility. So our strength is associated there, it's related. So as the mobility increases, and again, the shoulder joint has an increased mobility, the strength of that joint decreases. Our shoulder joint is very weak compared to our sutural joint between the two parietal bones. You hear of individuals dislocating their shoulder due to the strength of that particular joint. You never hear of someone dislocating the sagittal suture. So the strength of the joint is very tightly tied to the mobility of that joint. We can classify joints two ways. We have a functional classification, and this is the classification that we're going to run with. And the functional classification is based on that range of motion. And the other way that joints have been classified in the past is based on their structure. And I'll introduce this, I'll mention it, but we're not going to focus on that. We're going to focus on the functional. You'll have to excuse me, I have some allergy issues. Functional classifications. We have 3 main classes. Joints can be synarthroses. These are immovable joints. There's no movement. One of the things we'll see with joints is there's often connective tissue. Here we're specifying fibrous or cartilaginous, separating the two bones. So synarthrotic joints, they do not move. They have either fibrous or cartilaginous connections between them, and often they can fuse over time. A good example of a synarthrotic joint would be those sutural joints. Here's our sagittal suture, here's our lambdoid. These joints may fuse over time. Okay, some of the specimens in the lab, the actual suture itself was very faint, and it was in some process of fusion. Amphiarthroses are slightly movable joints. They provide some movement. It's not a lot. And again, you're going to find this fibrous cartilaginous connection in between. Just an example of an amphiarthrotic joint would be the pubic symphysis. This is that joint that forms between the two pubic bones. And it does allow for some movement, but not a whole lot. And lastly, we have the diarthroses. These are the freely movable joints. This is what you usually refer to as a joint. Well, you might not refer to it, but when we think of joints, the knee joint, the shoulder joint, these are all diarthroses. They allow for a tremendous amount of movement. They're also known as synovial joints, and we'll divide these based on their type of motion. So again, as we go from the synarthroses to the amphiarthroses to the diarthroses, we find that mobility is increasing. The diarthrotics are the freely movable, amphiarthroses are slightly, and the synarthroses are immovable. So as that mobility increases, we find that the joint strength is decreasing along that same line. So we have strength increasing as we move from the diarthrotic joints to the amphiarthrotic to the synarthrotic. So just keep that in mind. You probably can't read the writing there, but it all refers back to that that statement I made a couple slides ago. All right, this is how we structurally classify joints. They're bony, fibrous, cartilaginous, or synovial. Again, we're not going to focus on structural classification. We're going to look at functional. So I've introduced it, but don't focus on it. All right, the functional classifications, the synarthroses. Again, these are our immovable joints. They're very strong. We often find that the two bones often either touch or interdigitate or interlock. If you remember looking at the sutures of the cranium, they interlock. If this were the sagittal, you have the left and right parietal bones, and they interlock. Again, this situation, it increases the surface area, which is going to increase the amount of surface that is in contact, which creates a very strong joint. Synarthroses are found where movement needs to be prevented. We obviously don't need the plates of the cranium moving around, the bones of the cranium moving around. Examples would be the cranial sutures, where a tooth fits into its socket. This is a type of synarthrotic joints. Your teeth should not be shifting around. And then synarthroses are found associated with the both the epiphyseal growth plates as well as the growth lines that are associated with maturity. Now, all of these types of joints have specific names. The gomphosis for the tooth in its socket, synchondrosis, synostosis. Don't worry so much about this terminology. If you know that they're all synarthroses, will be good. The amphiarthroses, these are slightly movable joints. Again, they're going to be stronger than the freely movable joints, but slightly weaker than the immovable joints. And there are two types of amphiarthroses. We have the syndesmosis. This is where the bones are connected by ligament. Here we have the distal tibia and fibula, and they're connected via this little ligament. And this is an amphiarthrotic joint. And then the symphysis. Bones are separated by fibrous cartilage. If we look at the body of the vertebra, they are separated by a cartilaginous pad forming a symphysis. And then lastly, we have the synovial joint, the diarthroses. These are your freely movable joints. Diarthroses tend to form at the ends of long bones, and they form within an articular capsule. Let's see if I can change my color. Surrounding the ends of these long bones, we have a capsule that contains the joint itself. So that is, again, referred to as the articular capsule. There are a lot of components of this capsule, and we'll start with the articular cartilages. The articular cartilages are the pads, the cartilaginous pads that line the ends of the long bone. Here we have it right here. And between these two pads, we find a fluid known as synovial fluid. The idea of the synovial fluid, or the function, is to reduce the friction. So the two long bones actually do not touch. There's always a thin layer of fluid between those two bones. Synovial fluid, it's very similar in composition to the interstitial fluid. With the exception of synovial fluid contains a lot of proteoglycans. You should see protein and sugar, because this is a very large sugar, carbohydrate, that is attached to a small protein. And proteoglycans are secreted by the fibroblasts. Functions of the synovial fluid: they lube, they help distribute nutrients to all the cells that are within this joint capsule, and it serves as a shock absorption. As you jump, the weight of your body presses down on the knee joint, and the synovial fluid helps to absorb some of that shock and distribute it evenly to the lower extremities. There are a number of accessory structures associated with the joint, and all of these help support the synovial joint. We have some other cartilages that help cushion. One of these are, we can identify some of these as being meniscus or menisci, or articular discs. If you jump forward one slide, you'll find a figure that has all of these accessory structures, and you'll actually see the meniscus. So this is a cartilaginous pad that helps to support the joint. We have adipose tissue deposition. We have fat cells, little fat pads within the joint to help cushion, support. And we're also going to find that ligaments help support. The ligaments, again, are going to help stabilize the bones of the skeletal system, so that it helps reduce the amount of movement. It just helps hold it all together. When we often hear of individuals spraining an ankle, for instance, and what you're actually doing is you're actually damaging the ligaments associated with that joint. These types of damage, or these types of damages, take a long time to heal. Individuals who sprain parts of their body are often experiencing pain and discomfort for some time as they're waiting for those tissues to heal. Tendons. Tendons attach muscles in and around the joint. we see here in the knee joint here, we have a tremendous amount of musculature. It's not all identified, but we see both in the lower and the leg, as well as the thigh. There's a lot of musculature associated, and these tendons help hold it all together, help support these tendons. I don't know if I said ligaments, but they're tendons. And then lastly, we have the bursa, or the bursae. These are little pockets of synovial fluid. Here we have a bursa. And bursa tend to form anywhere where tendons or ligaments rub. Both tendons and ligaments are made of dense connective tissues, and as they rub against other structures, they create friction. So little pillows or little pads of synovial fluid strategically placed help reduce that friction. Bursa are associated with two pathologies, bursitis and bunions. If you look on page 271 of your Martini textbook, there's a little clinical note that defines bursitis and bunions. Please make sure you've read that before the exam. It's likely to be on the exam. It's only 2 little paragraphs. So when we look at the different factors that stabilize the synovial joint, we have kind of a laundry list here. There's collagen fibers both in the joint capsule associated with the ligaments. We have the articulating surfaces, where we're going to find those articulating cartilages, as well as the menisci. There's bones, muscle, fat pad, other types of tissues that aid in stabilization. And then finally the tendons between the articulating bones. So all of these work together to stabilize and secure the joint itself. Injury to a joint includes, or it's formally known as dislocation or luxation, if you literally force the articulating surfaces out of position. And this again it can be relatively common. And when you think about which joints are dislocated most frequently, you would think the shoulder, because that is probably the weakest joint in our body. The weakest joint, but it has the most mobility, the most range of motion. I had a YouTube video of an individual dislocating a joint, but I don't have a way to show it right now. If you were to go to YouTube and search dislocation, you're going to find lots of very graphic footage of individuals dislocating joints and the pain associated with it.